What's it doing so close to the ground?
I think that's the question. And apparently it's being constipated, apparently.
It just seems suspicious. What is it up to?
Super sus. Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 60. We are still answering listener questions. Cheryl, what's the listener question happening today?
This week's listener question is from one of your coworkers, Ryan.
Yes, it is.
I have not met her myself. Her name is Jennifer. And is she a science teacher? What subject is she
is
teaching?
Not. So she actually isn't a teacher. She's, and I don't know if she's technically a paraeducator or an instructional assistant, but she helps support students who have extra needs throughout the school. So she'll be in different teachers' classrooms. She develops relationships with students, try to help support them. So she's in a whole bunch of different places throughout the day.
Oh, nice. So she probably is not sleeping through science, I'm guessing.
No, she is really interested in science, which is very cool. And she gets very excited, which gets me excited.
Yay. Let's hear her question.
All right.
Okay, so my question is, what is fog? So I know it's fluffy clouds and they're wet, but it's not rain. But they're like constipated clouds, like all this stuff is stuck and then out. And then why do they sink? Because sometimes they sink and you can see the sky above the fog. And then why they burn off, but then sometimes they don't burn off, so where do they go? Like, what happens to them because it's not warm enough to burn off?
Oh my gosh, I love her.
Isn't that great?
I can see why she gets you excited about science because she has such great ideas.
She does.
She's all pumped about it.
Yeah.
Yay.
And has like all, and she's clearly really thought it through, right?
Yes. What is fog?
Yeah.
Oh boy, Jennifer. Here we go.
So let's go into your pre-assessment, Cheryl.
Yeah, we already did hers. We heard she did her own little pre-assessment.
Yeah, which was great.
Yeah.
But what do you think? And feel free to build off of any of her ideas.
Okay. Well, I like that one of her questions was about them burning off because I have wondered, and clearly we just need a unit on weather, but I have wondered why there's more fog in the morning. Like I just don't think about weather being dependent on what time of day it is, because it can rain at any time of day or night, but there's some component where, like in parts of Southern California, there's fog in the morning and then it kind of goes away. So I'm curious how that's related as well. That's kind of a side thought, but constipated clouds might be my new favorite term for fog.
Yeah.
And I had wondered, like, are they a type of a cloud or are they different than a cloud? Are they like a subcategory or kind of their own deal?
What do you think?
I had thought they were different than clouds, but it feels kind of like splitting hairs in a way. You know what I mean? Is it like different than clouds or a subcategory? But because I'm not sure, like, if they would classify as a cloud, because I feel like sometimes people say it's cloudy and they're like, oh no, it's foggy. And so is it, like, is it different or is it like similar to how there's like cumulonimbus and different types of clouds, and then there's a fog. Does it have to be humid for there to be fog? Like, is it humidity to the point where it becomes fog? No, I don't think so. Because otherwise,
what do you
Florida
mean by
would be foggy all the time.
humidity?
Well, we also need to talk about humidity at some point, but just so much moisture in the air.
Okay.
Yeah, why would it be low to the ground? Because clouds happen when like the rainwater evaporates and it goes back up into the clouds, right? So
Okay.
does it just evaporate but not go very far if it's
Okay.
close to the ground? Are they heavy? Is that why they're close to the ground? Because they're constipated? Like they're so full of moisture that they can't float that high? What is fog? Oh my gosh. I don't
Well,
think fog rains. Clouds can rain and snow and
okay.
produce all this precipitation. And I don't think fog can make precipitation.
And why not?
Is it because of the level that it's so close to the ground as opposed to up high in the sky?
Okay.
But I don't know why that would make a difference as far as like why it couldn't rain from a fog. A fog.
A fog. So there's a really important question that technically I haven't heard you answer yet. So I'm going to go ahead and ask you.
Okay.
What is fog made of?
Oh, is it water vapor?
Okay.
No, you can't see water vapor, can you? Can you see it if there's enough of it? Because we talk about, we know you can see water vapor. You can't see water when it turns into gas form. But water vapor
Okay.
is the tiny, tiny little particles. Is it that? Is it made of water?
What do
Or
you
is there
think?
something else?
Do you think fog is made of water?
I don't know what else it'd be made of. So I feel like, yes, it's made of water.
Okay.
What's it doing so close to the ground?
I think that's the question. And apparently it's being constipated, apparently.
It just seems suspicious. What is it up to?
Super sus.
Oh, you are around teenagers.
I don't know what you're talking about. There are a lot of things to talk about with this. There were so many ideas that you expressed and Jen expressed, so I will do my best to try and encapsulate it all, but feel free to interject with more questions if I'm going too fast or being too random, okay?
Okay, sounds great.
All right, let's start with whether or not fog is a type of cloud or not.
Okay.
And the short answer is yes.
Okay.
Fog is just clouds that are at ground level.
Okay.
Okay. And
That checks out.
Yeah. Building off of that, it's not clouds that have sunk or fallen or were too heavy and are at ground level. They actually form at ground level as opposed to forming up high in the sky.
Okay. Okay.
And so what causes them to form, the clouds that are fog, is slightly different. I mean, fundamentally, they're still clouds, so it's the same thing. But because it's happening at the surface of the planet, it looks a little bit different as to what exactly causes that than what happens in the sky.
Okay.
Okay. And I'll get to what that is in a minute. Because it's all related to what clouds are made of, which you said water vapor or maybe a gas, and maybe one you can see and one you can't. And you had things that you remembered in there. So
Yeah.
water vapor and a gas are the same thing. And you can't see them.
So it's tiny droplets of water.
No, that's not water vapor.
No,
Clouds
but then
are
in
tiny
that
droplets
case,
of water.
Okay, that's what I'm trying to
Yes.
say.
Sorry,
Okay.
yes. Clouds are tiny droplets of water, or in the right conditions, they can actually be little mini ice crystals. So sometimes they're not liquid, sometimes they're actually solid, especially up in the upper atmosphere.
Okay.
And you can technically get that with fog too. It's just not as common. So yes, if you can see it, it's not a gas when it comes to water. And we talked about this a little bit when we talked long time ago about boiling and
Yes.
steam, if you remember that.
Yes.
And so steam is technically not water vapor because you can see it. And so those are those little tiny droplets. And you're basically making a little mini cloud in a sense for a very short period of time.
That's really cute.
Do you like that steam is a little mini cloud?
Yes, and now I'm thinking about my humidifier and that they're like little clouds in my home, and
Yep.
that's adorable.
Yeah, there you go. So you can make little clouds anytime you want. One of the other things that you mentioned that we need to kind of put in here to kind of put the whole story together is humidity. And you're like, well, we'll have to talk about that at some point. Humidity is
Yes.
actually a really big, important thing when it comes to fog.
Oh, okay.
We won't go into all of the details of humidity. And I need to do a little disclaimer that my description of how humidity works will technically be incorrect, but it's a common explanation because it's easier to understand. Okay?
Okay.
You might have heard this before, but warm air can hold, and I put that in quotes, more water than cold air can. Have you heard that before?
No.
Okay. So humidity, when we talk about it, is the amount of moisture that is in the air, the amount of water that is in the air in a gas form. Most of the time when we talk about humidity, we're actually talking about this thing called relative humidity. So it's the amount of water that's in the air compared to the amount of water that could be in the air. That's the relative part.
Is
And
this like 2% milk or something where you're like, what is a 2% even about?
I mean, it just means that it's a sliding scale because when the air gets warmer, again, this is the part that's technically inaccurate, but close enough for what we're doing. It can hold or absorb, in a sense, more water.
So it's grading on a scale.
It's grading on a scale, exactly, a sliding scale. There you go. And what that means, though, is if you have an amount of air that has a certain amount of water that's in a gas form in it, and you take that amount of air and you cool it down, if you cool it down enough, eventually it will reach a point where it cannot hold that same amount of water in gas form anymore.
Interesting.
And there's actually a name for it. And again, we won't go into all the details. That's called the dew point.
I've heard that term.
Mm-hmm. So dew, like little drops of water that you would find in the morning, especially like in the spring or summertime, is when the air cools down overnight to the point where that water can't stay as a gas anymore, and it actually turns to a liquid on a surface, like plants or your deck or a blade of grass or whatever.
That's why dew happens?
Yes. Again, oversimplification, but yes. And that's the same thing that leads to fog. And this also explains a little bit why we tend to see it in the morning more often. Because overnight, we don't have the sun heating things up anymore. And so typically, temperatures drop, especially near the surface of the earth. And so as temperatures drop, the air can hold less moisture. So as long as it's the same amount of moisture that's there, if it drops low enough, you can reach a point where you reach what we call 100% humidity, which is you've got the maximum amount of water vapor that the air can hold, in a sense. And if you drop the temperature below that, now you're over 100%. It can't hold that anymore. It turns into a liquid.
That's wild.
And sometimes it'll do that like on a surface, and sometimes it'll just do that in the air, and that can be fog.
Is that why there's more fog like at the beach?
What do you mean?
Well, oftentimes coastal cities get a lot of fog in the morning.
Mm-hmm. So
and
there's
there's the ocean right there, then I wonder, is that related?
It is related, absolutely. So there's actually multiple types of fog that are dependent on exactly what causes them to form. And there is one about forming near or over water, because obviously the water is a source of moisture, because you've got a lot of water there that can turn into a gas. And so if it cools down, but there's a whole bunch of moisture that comes in off of the ocean or whatever, that can more easily form fog.
Interesting.
Yeah.
And that's coastal fog.
Well, yes. So do you want the
Surfer's
names?
fog.
Do you want the names of the different types of fog?
Sure.
So
I
there's
like my name so far. But
coastal fog. I like that too. No, that's good.
yes.
So there's radiation fog. There's advection fog. There's freezing fog and evaporation or mixing fog. And that's the one that typically will happen near or over water. Is the evaporation or mixing fog. And so what exactly leads to the cooling and the moisture and all that stuff is slightly different for each one, but big picture, it's basically the same. And so that also leads to one of Jen's questions was about it burning off.
Yeah.
So technically it's not burning. Remember, we've talked about what burning means with combustion. Does that sound familiar?
Yeah. Yes.
Right. So it's not igniting. It's not creating carbon dioxide and water. It already is water, right? But what's happening is when the sun comes up, it starts to raise the temperature. And as the temperature goes up, the air can, quote unquote, hold more moisture. So it's not forced to be in those little tiny mini liquid droplets anymore. And it goes away. So it just turns into a gas and just is in the air. So it doesn't disappear per se, but it goes from a liquid to a gas where we can't see it anymore. And so that's how fog would, quote unquote, burn off.
And that's why it's related to the time of day.
And that's why it's related to the time of day. Exactly.
Interesting.
Because the coldest part of the day is usually right before sunrise. Because it's had all night to cool down. And then as soon as the sun rises, it immediately starts to add some energy and starts to heat it up. And so it doesn't mean that it's like warm immediately, but typically the coldest temperatures are right before the sun rises, which is typically when you would see a lot of fog in the morning. And then as the sun rises, temperatures warm up, the fog, quote unquote, burns off, and it's not there anymore. In general, obviously there's unique circumstances for all of these.
And can fog rain?
Fog typically does not rain, but it's kind of like what you said. It's already so low to the ground. And I think we talked about rain a little bit in an earlier lesson. Basically, you've got to have, when we talked about different types of hail and things, remember that?
Yeah, and we talked about snowflakes.
Yeah. And so the water droplets kind of have to be able to come together and get bigger and bigger as they form together. And then they get so big that they can't stay in the air anymore. And gravity pulls them down. And so
like
typically
the water faucet.
Like the water faucet, exactly. Look at you making all these connections. And so typically you have to have a whole lot more of it to be able to make that happen, which you can do usually up a lot higher in the atmosphere. You can have really, really big, thick, tall clouds.
Okay.
Be able to do that. Do you feel like that answers your fog questions? Or is it still a little foggy?
I see what you did there.
Yep. And now it's quiz time, Cheryl.
I don't know. It's all kind of foggy.
Yeah. Well, let's see if we can burn that off a little bit, shall we?
Gosh.
Alrighty. First quiz question. Is fog a type of cloud?
Yes.
Great. Look at that. You're off to a great start. Not that hard of a question, I hope.
No.
Question number 2. What is fog made of?
It's made of water.
Yep.
In liquid form.
Yes. Great. Next one. What causes fog to form?
When humidity reaches 100% and the air cannot hold any more water vapor, then that water has to turn into tiny little liquid water particles that float in the air but they're close to the surface because that's where the greater temperature changes
Yeah,
are.
we didn't really talk about that part of it a lot, but
Okay.
yes. Yeah. Good. And why does fog burn off as
Well,
the
it
day goes on?
doesn't burn off, Ryan.
Oh, it doesn't.
Nope,
And what
because
does it do?
there's not combustion. We're not lighting it on fire. Um, it can go through a phase change and
Ooh.
change back into water vapor, which is a gas. And then it's just a part of the air, but we don't see it like we see fog.
And what causes it to go through that phase change?
Typically, if the temperature increases, I'm going to say typically because I'm assuming there are situations where something else might happen.
Yep. Nope, that's great.
Yeah.
Yep. Why do we tend to have more fog in the morning?
Because the temperature drops overnight. And so all of that water vapor that was in the air when it was warm during the daytime might change into a liquid overnight, and then we see it in the morning.
Great. Last question. Oh, except I think you might have already answered this. If fog doesn't burn off, why not?
Well, maybe it didn't heat up enough, or maybe there was just such high humidity that some of it did change phases, but not all the way.
Yeah, those are both great possibilities. Nice job. Look at that. You're a fog expert.
Oh my gosh, that's so exciting.
Yep, you can put that on your resume now. Fog expert.
Yes, I will add that right now.
All right, sounds good. And we sort of did a unit with all of these questions from all of our listeners, and this is the last one for now.
Aw.
I know. Listeners can continue to submit questions. We will still answer listener questions. We love getting your questions, but we're going to move to another unit soon, which means it's time for a unit reflection. Are you ready to be reflective, Cheryl?
Yes, I am.
Oh, very nice.
Is that a good reflective voice?
Yeah, very good. Very good. What are some things that you found interesting in this unit where we answered a bunch of questions from our listeners?
I think something I found interesting was, we answered a lot of questions that were mine that I had wondered over time in the past and since we've begun this podcast. And it was really fun hearing what other people are wondering. And most of those things I didn't know the answers to either, but they just hadn't occurred to me yet to ask those questions. So it was fun seeing what was on other people's minds.
That's cool. Yeah. What were some things that you found challenging?
Oh gosh. Well, part of it was trying to represent the question askers well. And I mean, because I don't know like what details they do or don't know about their questions. So hopefully we got their questions answered and they didn't just think I was really dumb or something. But so I think that was challenging, just trying to get inside of somebody else's mind. Because as you and I have learned with these questions about science, they can go in so many different directions based on what follow-up questions are involved on top of that initial one. And then just, man, any of the memorization is really challenging with science, whether it's memorizing the term for something or those little details can be really challenging.
Yeah, they definitely can. The details are what make it challenging, but they also are what make it work in the long run,
fair.
which is what makes it challenging at the same time. It kind of feeds on itself there.
Yeah.
Last reflection question. What concepts do you think you might remember or that might stick with you?
Ooh. I mean, the one that I felt least knowledgeable about was the space one.
The vacuum one?
The vacuum, yes. And just I know so little about space. And so that was really exciting, learning something and seeing how those concepts are still related to other concepts that I've learned about.
Mm-hmm.
And so I think that will definitely stick with me, that science doesn't suck. Um, and I think also just continuing to approach the world asking those questions and
Mm,
thinking through, like asking why a dripping faucet has a pattern is like not a question I would have ever thought about. And that there's a scientific explanation behind it is
mm,
so cool. And so it's
mm-hmm.
fun just keeping my mind open to what other questions I have about the world around me.
That's great. I love that. One of the things that surprised me, I know you're reflecting, but I'm going to do a little reflecting too. One of the
That's
things
fine.
that I was surprised by, but also thought was really cool, was how we took a whole bunch of just questions from all sorts of different people and just picked the ones that we kind of liked and stuck them together. And then there ended up being connections between the concepts of these other questions from different people that didn't talk to each other and didn't know that they asked each other questions. And we didn't intentionally try and make any connections between them when we arranged them. And yet they're still interconnected concepts, which is one of the things that I love about science, because it technically is all explaining the world around us. So being able to see those connections, and you made some of those connections yourself. And I always think that's cool.
Yeah, that was really fun.
All right, I think that's all the time that we have left for this lesson and for this unit. So why don't you go ahead and pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science, or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
Ah! The bell doesn't dismiss you. I dismiss you.